Hello and welcome to a special edition of the Teardown Sessions from Crowd Supply. I am your host, Helen Lee, and with me is Xobs, whose name is Sean Cross, but is better known as Xobs. So today we're doing things slightly differently. We're not coming from my studio, and we're not doing it on a Friday. Obviously, this is a Saturday. We are hosting or co-hosting an open hack day here at Portland State University with CETI. So there's all sorts of people hacking away over there, making things with LEDs and all sorts of fun electronics. And we're going to go over there and take a look at what's happening. But before that, we are going to talk to Sean about his latest project and see what he's up to. So this is as I say, this is the first time we have done this in person. So please do, if the sound quality is bad or it's too echoey, please do pipe up in the comments so we can adjust as necessary. This is a bit of an experiment for us. We've never gone live from an event before, so please do let us know the ways in which we can improve it, and we will attempt to do that on stream. So without further ado, over to Sean. Would you like to introduce yourself to the lovely people?
Sure. Hi, my name is Sean Cross, Xobs. And this is the first time.
Is it weird?
It is a bit
weird. Do you want to hold it like this? I don't know. Like.
No, I mean, so usually when you do this, it's people have trouble holding a microphone in general. That's why this is a lapel mic that's supposed to be pinned. But I'll just hold this.
That's what we got.
It's all about hackers and doing the best you can with what you've got and making something really amazing.
Exactly.
So we're here in Portland at not Teardown.
Not Teardown. Teardown weekend, but Teardown was cancelled because apparently there's a pandemic going on.
Something like that.
Yeah, something like that.
So that's what we're actually in the university building right now, which is why we're both wearing masks, which is a bit different.
Yes.
So I've done things with Crowd Supply many times in the past, starting with the Novena open source laptop, which I think is still on the Crowd Supply.
It is. People still love the Novena. The Novena gets brought up all the time. It was for those of you that don't know, the Novena was the first open source laptop that Xobs worked on with Bunny Huang, and that was. Would you say that was the first big project, big piece of hardware that you worked on together, or?
I think it was definitely the first big piece of hardware that I did post Chumby. So originally we worked on.
Of course, you were a Chumby person, weren't you? Oh my goodness.
Yeah. So originally Chumby was the first. Probably one of the first open hardware projects. It was basically a squishy alarm clock, and that's what brought me to Singapore.
Is that why you moved to Singapore?
Yeah, it was Chumby that was originally the impetus for moving to Singapore. And after Chumby, we decided to do open hardware projects. And previously, all of the Chumby mainboards were named after places in World of Warcraft. So we had Ironforge and Stormwind. And after Chumby, we decided that we were going to name the project after train stations in Singapore. Okay. So Novena is one of the train stations. We had Kovan, we had Siglap at one point. So Novena was definitely the first of the big crowdfunding projects that we did.
Yeah, but you've done several together. I mean, there's the Novena, and of course, the most recent one that you both did together was the Precursor, which is still in manufacturing.
Yeah, well, we actually have we've delivered the first batches of Precursor.
Yes.
So Precursor is spun out of the Betrusted project.
Good point. Tell them what
Yeah. So the Betrusted project is an FPGA-based secure communications device. Ideally, eventually, it's going to be full top to bottom open hardware. But for now, we're starting with an FPGA, simply because we can iterate it and we can audit it a lot more than closed source silicon. Betrusted is supposed to be the kind of secure communications device you could just pick up and use, but that's really hard to do. So we're doing Precursor, which is just the hardware, and we're still working on the software. But you can get Precursor now on Crowd Supply. One of the more interesting things is that it's done entirely in Rust. the kernel, the operating system, everything is written in Rust, just so you know that it is not going to be, it's not going to have undefined behavior. It's going to do exactly what you tell it to.
I will say, if you're interested in what Xobs was just saying, do you prefer to be called Sean or
Sure,
Xobs?
Sean.
Do you care? Sean. Okay, fine. Sean. If you are interested in the Betrusted project, I would highly recommend you go over to the CCC database of past talks, because Bunny gave a really great talk on basically hardware attack surfaces in, I think, 2019, maybe?
2019.
Yeah, 2019. So the Congress, the CCC Congress it was in Leipzig then. It'd be Hamburg next. Benny did a really good talk on just understanding hardware security and in the context with which they're working. It was a very interesting talk, so I'd highly recommend you look that up. So yes, there's the Betrusted, and then moved into the Precursor, which is now where's the Precursor now? Where are you at, Ben?
So the Precursor, we've actually delivered it to customers. We have people who are working on it now. They've added all sorts of fun features, like there's a what is it, TOTP. So you can actually use it in lieu of Google Authenticator, and
Nice.
it's got kind of a nice feature in that you can actually plug it into USB, and it'll type in the 6-character OTP or type in passwords for you. And you know that there's not going to be any sort of backdoor in there, just because it's fully open source, top to bottom, even down to the CPU. Like, we even have the source code to the CPU, which is Vex RISC V, which it's very rare you actually get down to that level.
Yeah, it is. Although you're seeing more and more. I mean, I've seen actually one of the things that, I mean, it's not launched yet on Crowd Supply, but it's just come out on the pre-launch page. It's our first board that uses a fully open source chip. And when I say a fully open source chip, I mean including the techniques in which it's made. So the Google Skywalker project.
Skywalker.
Yeah, Skywalker. It's one of the shuttles that's come off of that. Someone's done a ham radio chip, so they're doing SDR stuff, but it's literally I'm very excited about this being open source all the way down. It's a really open source silicon is something that's very exciting to me. But yeah, it's very cool. So we do have also some exciting new hardware on the table from Sean. So why don't I give this to you, and I'll go and get my down camera, and you can tell them a little bit about what you've been up to.
Sure. So one of the things about Precursor is that you program it using a Raspberry Pi initially. So the initial startup is done by plugging it into a Raspberry Pi, which does things like programming the FPGA, programming the ICE40, debugging it if necessary. It runs off of 1.8 volts, which is a little bit lower voltage than usual, and not everybody has a Raspberry Pi. So I decided to put together this project called Farpatch, and the idea with Farpatch is that normally,
Which one shall I show?
This is called a Cortex debug header, Cortex M debug header. It's got 10 pins. 1.27 millimeter spacing. You get this on a lot of development boards.
I should have redone my nails.
So one of the pins is the VT ref, which is supposed to be the voltage level of the target board. And this is supposed to be, when you see a 1 is this many volts. Mm-hmm. And normally you're supposed to draw something like 500 microamps, 1 milliamp, that sort of thing. Yeah. But I thought, what happens if we draw half an amp, which is what Wi-Fi chips use? And it turns out most boards are fine with that.
Oh, really?
Which means you can actually power a full Wi-Fi chip off of the off of.
To get that the right way. Here we go. There we are.
Yeah, and so this is an ESP32. The USB is just there for debugging. We can actually remove it on the final version, but it's nice to be able to not brick a device if you misprogram it or something along those lines. And this is nice. It's because it's powered off of the target. It has a buck boost, and so it's good for 1.8 volts all the way up to 5. Just plug it in, and you can debug something anywhere. One of the ideas behind this is that if you're doing something waterproof, like a submarine or originally I was doing a dragon boat paddle stroke counter.
Yeah.
If you put it in a waterproof case, you can't update it anymore. You can't do it without adding an updater, and then you can't debug it. But with something like this, you can actually put this inside along with it, and then you can continue to develop it when you actually find a bug.
Oh my god, that's so useful.
Yeah.
That is actually incredibly useful. I hadn't actually read the blurb on what young. Like, to be honest with you, like I hadn't read the blurb like fully on Farpatch, and I'm very oh my goodness, getting notifications on my phone and trying to swipe them away. This is it's a really great design, and I love the PCB color as well.
Yeah.
Is that like,
it's a custom color. I just asked the
really
foundry.
Nice. It's like a teal color. Actually, look, it matches the background.
Yeah, it does.
Okay, we've got a question here. So Newgard is, I don't know who Newgard is, but hello, who you are. Newgard says that our audio sounds good. That's great to hear. And also asks that, so he says, I see that the Precursor is part of a Silicon Labs accelerator. And what components from Silicon Labs does it use?
I believe the Wi-Fi chip is a Silicon Labs part.
That tracks.
Yeah, and the reason why it's not an open Wi-Fi chip by any sense, stretch of the imagination. But then again, very few parts are. Even ESP, Espressif, which is what Farpatch uses, the libraries are all closed. It's just a blob. And when we originally designed Precursor, I think it was the ESP8266 was the dominant one from Espressif, and the Silicon Labs part was more available and had better standby power. So I think the Espressif chip ended up drawing a bunch of power when it first turned on, whereas the Silicon Labs chip didn't.
Did you have any trouble procuring that part?
Of course, everyone did.
It feels like you can only get ESP32s or RP2040s at the moment. Everything else, you've just got to murder somebody to get.
Yeah, it's true. And in fact, it may be the case that if we redesigned it, we would put an ESP32, especially since I've done Farpatch, so I'm a lot more familiar with how the ecosystem works.
Yeah.
But
what are the other boards that we've got here?
So those are
we've got to show this bodge. So one of the things like Xobs, Sean is known for is like ridiculous soldering. I think that was the first thing. Like I saw that ridiculous like magnet wire solder on. Was it the Precursor prototype?
That was FOMO, and that was Bunny's soldering job. So that was
right. You're right. You were sat next to him.
Yeah.
You should have taken credit.
I know. I'm terrible at soldering, and this is evident. But this is.
Look at this.
The problem
You're
is
terrible at soldering.
Yeah, Espressif is. They have really weird names for their SPI. Pins, and it's 4 wires: DI0, DI1, DI2, and DI3. I connected D0 to DI because I looks like a 1, and I connected D1 to DO. And so this bodge is just swapping them around so it works at all. I've since realized that I need to fix it.
Is this the fixed version?
That's the fixed version, yeah.
What's happening on this board?
What's happening on this board?
Yes.
So this is just a simplified version of Farpatch. So this is a previous version of Farpatch.
This is we've got like version 1, version 2, and this is the final version. Okay.
Yeah. So the previous versions didn't have any sort of power regulation whatsoever. So they're smaller.
This one and this one didn't have any power regulation, and this one is this the one that's gonna? Have you got any more design revisions to do?
Yeah, there's one more design revision that puts a giant super-capacitor on there.
What's that for?
It turns out that some boards don't like it when you drive 400 or 500 milliamps off of them. in particular Nordic, because Nordic makes very low power parts. They don't really anticipate it. This uses several times the power budget of like a Bluetooth radio. So if you put a giant super cap, 3 or 4 farads, it can ride through the times when it's transmitting and using a lot of power. Also some other, we're doing some. So this is based on the Black Magic project,
which is by Peter Esden.
Yep.
The lovely Peter Esden, also a Crowd Supply creator.
Yeah, so it's based on that. And one of the things we managed to get is you look at this connection right here, this connector. Yeah. So this I mentioned is a standard 10-pin Cortex connector. We actually have an addition to this, an extension. Ooh. That there are 2 spare pins in there that Blackmagic supports this and Farpatch supports this as well. You can get a serial console through there, which means you can actually just have one device connected to your board that's potted inside of a waterproof container, and you don't need to solder anything. It just works.
It just plugs in. That's fantastic. Yeah. I do want to ask you something else, but before we move on, I'm gonna. So Peggy has come online and she's asked, when will we see this on Crowd Supply? It's a good question. Do we know?
We don't know yet. So one of the nice things about being up here is that I can actually give Crowd Supply these. There's a pre-order page up, yes, and all of the pre-order photos are taken with my phone. Crowd Supply has some very nice photographers.
We do.
And
so is this the one that's going to be photographed? Are you leaving this with us?
Yes.
Oh, nice. Okay. Very cool. Yeah. So we do have we have a photography studio up here. So we do all the photographs for all the people who do. Because not all engineers are good at photography. Who knew? Who knew?
Engineering has some very strict rules, and photography has a couple of strict rules. But when you get into things like lighting, the rules get kind of fuzzy.
Yeah. So do we have a ballpark time for when this might be available?
I'm not sure. Was 1 month maybe? I mean,
there we go. Ish. At some point before Christmas.
Yes. Before Chinese New Year, for sure.
Okay, well, in essence, I did actually want to talk to you a little bit as well about, I wanted to ask you about Singapore. This is only for my own curiosity. So you went out there for Chumbi, and you've stayed there for how long now?
It's been 13 years now, I think.
13 years. So why did you stay? Is there did you enjoy the hacker culture? Did you just get work there? Was it love? Or you just like Singapore? Because you're American originally. His accent's almost as messed up as mine is after having lived outside of the country. So I'm curious to know, what is the hacker culture like in Singapore? And it feels like it must be easier to manufacture things because of your proximity to Shenzhen and Guangdong and that kind of stuff. Is that true?
Yeah, well,
is there a lot of hardware in Singapore?
There is some hardware. There's 1 or 2 buildings that are large where you can get parts from if you need them. DigiKey and Mouser they have 72-hour delivery usually, unless there's a customs issue. Wi-Fi chips tend to get caught by customs a lot. The proximity to China is very useful for manufacturing because it means you can talk to people who own very large machines without owning the machines yourself.
Yeah.
So, for example, CNC machines, if you know somebody who has a CNC factory who does CNC for a big company, but they really, really love CNC, you say, hey, can I run a couple of cases through it? And maybe you can advise me on the best way to redesign this because you're a professional. So having access to that was a very big reason for being in Singapore.
So that manufacturing it's not necessarily the PCBA stuff, but the other stuff around product design is much easier by you being out there.
Yeah, for sure.
Do you still get PCBs from China, or what do you do?
Yeah. So these 3 PCBs we have here are 2 of them are from PCB Way, and one of them is from a company called King Creddy. The prettier one is from King Creddy.
King Creddy. I've not
Yeah.
heard of King Creddy.
Um,
Is this like are they a small manufacturer? Or?
they're reasonably small, but they are they're not cheap is the problem.
So it's like high end. Was it PCBA or PC? Do they just are they routing the boards? What process are they part of?
So originally they are a PCB house, but they subcontract to assembly as well. But they just the guy loves PCBs, and so you can ask him to do any sort of crazy thing. I gave him a vague Pantone color for the PCB. Most boards would be like, no, you get red, green, or blue, or yellow, I guess. He's like, yeah, sure. If you're paying for it, let me mix up my solder mask and get you a color that's vaguely like what you want.
Yeah, it is a really unusual color. It's kind of like a deep mint green in real life.
Yeah, no, I was trying to think of
what kind of cost. I mean, how many did you have to get in order to get a custom color PCB?
So the problem is you get a board like this, and what they do is they make a panel with everybody who's made that order, and then they slice it up and give you your board. And so they take the cost of one panel and divide it amongst everyone. For something like this, what King Creddy does is they run your board. So the setup cost is relatively large, $300 or $400. Actually, I think it's about $300. And then each board is just an incremental cost on top of that. It's dollars on top of that. So it's a different way to do it, but you get a lot more custom. And this is how most production boards are done. So it's kind of nice to do this high-end one, just to make sure that everything works in mass production.
What kind of volume are you doing in order to do that, or is it just you pay that $300 and you could buy like 10 boards or whatever?
So for this one, I did 10 boards.
So you paid $300 plus $10 basically.
Yeah,
for the individual boards.
For the boards, and then there was assembly on top of that, which was expensive because they have to.
That is an expensive prototype. But it is. I mean, it's useful to know that there are PCB houses that will do like short-run custom colors. I think that there might be quite a lot of people who'll be interested in that information. What's the name of it again?
King Creddy is the name.
King Creddy. How do you spell that?
Creddie.
I'll put it in the show notes for those of you who are watching this afterwards, which is most of you. So we'll put it down. We'll put a link in the show notes if there even is a link, or do you just have to WeChat somebody?
No, there is a link. Although it's one of those things like you go to PCB Way or all PCB, and there's only one D. Okay.
Like that. There we go.
It was originally King Credit, but I guess the E they decided they'd like that better. But I believe what happens now is it's like PCB Way or JLC, where you actually fill out the forms you want, and at the end it ends up turning into an email. But the guy does really good work, and he really loves what he does, and he's willing to do just about anything with PCBs. Willing to entertain them as long as you pay for the research and development.
That sounds awesome. So an experimenter. Yeah. That sounds really great. And what about do you have are there hacker spaces, or do you just hang out with your hacker friends there? I know a few people in Singapore, and I'm wondering what the community is like.
There is a community. The problem is space is very expensive. And so, for example, hacker spaces, there have been a few. They've all been very difficult. One of the more interesting things is power tools are very difficult to come by.
Really?
So I have a.
You mean drops or drills and saws and that kind of stuff?
Yeah, exactly. So I've been looking for a router to cut some wood. Yeah. Just there's nowhere to be found. You have to find somebody with a garage and make friends with them.
There's no shop bot that you can hire.
Nothing like that. No.
Well, yeah.
Plus, where would you do it? Because everyone lives in an apartment. So.
This is true. Yeah, this is true. Oh no, that's that's actually one of the reasons I was keen to move out west. The West Coast is just the space, the access to space that you get here is much more than, I've been living in European cities, which aren't quite as dense as Singapore, but not too far off.
Yeah, there is a conference that goes on called FOSS Asia, and they have FOSS Asia Singapore.
Is it good? I've heard about it.
Yeah, it's been a couple of years since they've actually held it in person. Actually, just as the pandemic was hitting was the last one. There was one that happened, I believe, this year, and I actually spoke in that. But it's been a while since they've held it in person.
Yeah.
Like everyone else.
Yeah, I mean, this is why we're in a small room with like some 20 people in masks as opposed to 300 people at the other venue, because doing things in person is more difficult these days. We can just try and move forward and take it as it comes.
Yep.
So I had another question I wanted to ask you, but it has completely disappeared from my mind, of course. But yeah, I wanted to. So you're done with Precursor as far as you're concerned. And what's the different workload? Because you and Bunny work on a lot of different things together. So did you work on the OMUs as well together? Or was that just you?
That was just me. The TOMUs, the FOMUs, the COMUs.
Yeah. The OMU is not, you created a form factor basically.
Yeah.
That's pretty cool. Not many people have created a form factor. Do you want to tell people about what the OMUs are? Because not everybody knows. So tell them about the OMUs.
Yeah. So the OMUs were actually Tim Ansel Mithro. It was his original idea.
Was it now?
It was, yeah.
I loved him. He's one of my favorite technical speakers.
He's very good at it.
Yeah,
he's very good at speaking.
He is. I like him, yeah.
And so the idea was he was upset at the cost of YubiKeys, the little authentication tokens. So he decided to take a Silicon Labs part and something like 7-8 components on the board and turn it into a very tiny computer that fits in a USB port. And I took this. This is my first by myself project with crowd supply. Was crowdfunding that. And the fun part was one of the stretch goals was to get a plastic case for it. Because originally you were supposed to wedge the board in your USB port with some paper. So we built a plastic case for it. I got
injection molded.
Injection molded, yeah.
I'm going to come back to that because I've got questions about that. But go on.
And I actually got somebody in China who loves injection molding, so I got him to critique the design and improve it and add. You actually design the tool. So actually, in the Tomu hardware repository, we have the step file for the injection molded core. If you ever want to see what one of those looks like.
I do. I love hearing about people's injection molding. And I was speaking with, one of my guests, I guess like a couple months now, was Robin Reiter, who did the Pixel Pump, if you've seen that, which is like an open source hardware, like a manual pick and place. It's a vacuum tube, like foot operated. It's really nicely executed. But he's done the first version of that. A lot of everything was 3D printed, of course, and we spoke quite a lot about the process of taking a 3D print STL and basically because it's completely different, right? So you've got to achieve the same kind of shape, but using a completely different technology. I found it very interesting. I've actually gotten to go to a couple of injection molding factories in China. It's fascinating. But how many did you do? Because injection molding only comes into play when you've got how many did you have to do in order to make that worthwhile?
So the original stretch goal was, I think, if we hit $5,000 or $6,000, we would do the tool, which we hit. I think we've done 3,000 total, 3,000 shots. Or sorry, there's 4 per shot. So 3,000 pieces.
What do you mean by shot?
So when injection molding is this big chunk of steel, really, really massive. And what happens is it closes. Liquid plastic flows in, it solidifies, some pins move to actually eject it, and then it opens up again, and you have pieces. So that is one shot, is one cycle of this injection molded plastic. And in the mold that we used, you actually get 4 cases out of a single shot. So for 3,000 pieces, it's 3,000 over 4. I'm going to say 4,000. 1,000 shots. Because I think we actually
1,000 shots, but then you've got to buy the tooling. That's the expensive part, right?
Yeah. So the tooling is basically buying several kilos of steel, just because it's a big chunk of something like this big, and it's heavy. Steel is expensive, so it's mostly the raw price of steel.
And how do they, is it CNC milled to get the mold? Do you know how they do that?
So I think what they do is they CNC a block of copper that they then use EDM to electron discharge molding to actually get the steel cut. So they don't CNC the steel directly. They first go through as much softer metal copper, which they then use to basically to suck all the material off of the steel tool. And then they bake it, which results in a lot of smoke. But I don't know if you've ever seen EDM as a process, but it is gorgeous. Just because it's all this very, 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 very shiny copper in these gorgeous baths of really poisonous material that is just very pretty.
Danger Lake.
Yeah.
Wow. Yeah. No, I would like to see that. I like getting to see industrial processes, but that's now that's on my list.
Yeah. So because we had done the TOML, we eventually did the FOML, which is an FPGA based one, which is an ICE 40 UP5K, where we actually implemented the USB in a gateware inside the FPGA itself. And again, because injection molding is expensive, we used the exact same case.
Oh, you did? Yeah.
Actually, no. So the case was slightly different because when you do injection molding, you have this big core, and then you have inserts that you could put inside. And the core is basically it's four pieces. It's the top half of the core, the bottom half of the core, and then the top half of the mold and the bottom half of the mold. So what we did was we replaced one half of the core, which is about this much. Okay. Which is a lot less steel, and is much cheaper.
Yes.
So we reused the other half, which cut the cost way down, and meant that we could have a custom PCB layout with different heights and such of the components. Overall, it meant that we could have a case for much cheaper. So we didn't even bother with the stretch goal because it was only a few $100 to get that.
Yeah.
And then after that, we did Cuomo, which is Quick Logic. It's their half ARM core, half FPGA, which had the same form factor.
Yes. So. Yeah. And there's other people that have taken it and started doing little OMU form factors as well. That's got to feel good.
Yeah. I think there's a
Femto,
which we really thought should be called Womu, but
Have you met Femto? He's really nice.
No, I haven't.
Yeah, he I think I met him at the Bringer Hack at the last Maker Faire. But yeah, he's really nice. He makes lots of small things and very small things. So I think he was drawn to your form factor.
Well, apparently the OC Maker Faire is going on right now.
Oh, really? OC as in Orange County?
Yes, Orange County.
Okay. Oh, well. They got away with that then, didn't they? Funny what you can get away with. Okay, so it is now, we've been talking for half an hour, and before we sign off, I do want to go over to the other space. So for those of you who are with us, I would like to go and show you some projects that's going on in the hack day over in that other room. Hopefully the university Wi-Fi will stay with us. And we will be able to take you over there, but please bear with us if things drop out in the next minute or two. We're just going to walk over there and show you around. The. Okay, so would you be able to take my laptop and I'll take my phone? Here we go. All right, here we are. The first time the stream has gone on the move. You can leave the case here; it's fine. And we'll take this. Oh, hang on. Wait, I'm actually gonna unsolo us so you can see both of our. There we go. Look at that. That's very exciting. Look, we're walking around PSU. It is a fairly personality-free university. Where
it's the weekend. It is Saturday.
It is Saturday, but the lab is really cool. We've been doing quite a lot of tours of different places recently, so it looks like stereo vision. Look, it's just a plug for Stereo Pi. Oh dear. All right, here we go. Let's see how this is going. All right. Well, if it's going to get a bit noisier in here, but hopefully the mic will play. Let's start off here. Let me just put my bag down. A second. I'm actually going to solo the phone. there, and then you can just pop that down. Making noise, probably. Hi, Darcy. Hi.
How's it going? Hi. I'll hold on to it for a minute if you want me to, or you can hold it.
Yeah, I'll hold it.
Okay.
So this is Darcy. Darcy also works at Croxx Supply now.
Yes.
Can you tell me what you've been working on?
Yes. So for this weekend, over the course of 2 days, my goal has been to build a game of MIDI activated Twister. Just a fun, interactive piece, because why not? It feels like a fun thing that should exist in the world.
I agree. I fully agree.
Yes.
And what's this PCB? Are you reusing this, or this is your own design?
No, this is a MIDI keyboard that I have hacked.
Oh, nice.
I have the microcontroller. We could do this in code in Arduino or something, but just for time's sake, because we only have 2 days, I decided to hack a MIDI keyboard instead. So I went through yesterday and tested everything to kind of figure out what actually triggers the notes to send a MIDI on message, and determined that if there's 2 different points on each contact point that's bridged together, then whenever it touches, then that will trigger the MIDI note.
Nice.
So I went ahead and bridged together these, I believe they're diodes, these components on there. So that way the 2 connection points are bridged together correctly, so that I'm going to be able to then solder wires to come off to go into all of these terminal strips here, which will then go out to the board over there.
Very cool. And this is going to be the interface, the twister.
Yeah, and I made 2 example pads yesterday for like how to put it together.
What is this? This is copper.
Yeah, this is just copper tape that I'm just using for contact points, and then I have a big roll of 1-inch high density foam to kind of keep it spaced apart in between. And I already figured out how to wire it all together, so I've kind of got everything all mapped out. I've got a couple friends coming later to come and help assemble everything. So the goal is to see if we can complete this by 4 p.m. today. Fingers crossed, you know. If you want to come help, just come show up to the CETI Lab. I'll put you to work.
Anyone who wants to come, this is an open day. You are welcome to come along as well. As long as you're masked and vaccinated, we'd be delighted to see you. Yes. We've got lots of cool things. I'm going to take a little look around. Thank you for showing me your project, Darcy.
Yeah, absolutely.
Yay. Let's see what we're working on here. We've got an Oscar Tone Scout over here. Can I take a look? Like a little bit of open source, love as well.
Yeah.
Very cool.
Yeah.
Love the Oscar Tones when we're putting that together. And here we have a backpack 3D printer that I think Miguel made. I don't know where he is. Oh, he's over there. Oh, I think my Wi-Fi is not doing super well. All right, I'm going to come over here because I know we've got some robotics coming on. Hi there. Can you introduce yourself? I'll hold it.
Hi, I'm Pierce Nichols.
What are you working on?
So I work on sailing robots. Oh yeah, I just powered this up with a switch in the wrong position, so it's upset at me. That's not, there we go. And I didn't bring the whole sailboat because it's kind of big.
It is quite big. I don't think you could fit a boat in. You couldn't fit a boat in this. Well, you actually could. It's quite a large lab.
I could have carried the 5-footer, but I didn't.
So what's this?
So this is the brain box for our 5-footer. There is a Raspberry Pi Zero under this, and then there is a Pixhawk 4 there, which is sort of the main control for it.
I'm gonna come around the side.
This is just power distribution. GPS lives. Yeah, this board's just power distribution from another battery box. The GPS is there, and then the let's see. This is our wind sensor plugs in there. The 2 wing sails plug in there, and the 2 rudders plug in there.
So is it an autonomous?
More or less
Autonomous sailing boat. Cool.
Yeah.
I'll let you get on with your hacking. Thank you so much for showing us around.
Yeah, and we've got the more advanced cousin of the Pixhawk 4 in there. We get the 6X, which just came out. So I'm doing some setup there and making it play with PX4's new mixing software.
Very cool. Thank you for showing us around. Oh, I've got that same sticker on my suitcase.
Which one?
The stolen robotic head of Philip K. Dick. I don't even know where it came from. Someone just gave it to me at SuperCon, I think.
Okay, so as far as I know, there are only 50 of them.
50?
That
I've got one of them.
One of my co-founders made them. So the way it came to happen is that one of my co-conspirators for the selling robot stuff one night told the story of how the robotic head of Philip K. Dick vanished. Like so after Philip K. Dick, who died, some fans of his made a robotic head of Philip K. Dick, and they were taking it around to conferences, and after a conference while they were flying home, it vanished.
It vanished.
Yes, neither hide nor hair has been seen of it since. And where I grew up in New England, there are a lot of like old houses will have a plaque that says something like George Washington slept here. There are probably more of those plaques than there were days in his life.
Almost certainly. Well, I found out the backstory of a sticker that I picked up at a hacker conference, and I've always wondered what it meant. So thank you for that. Thank you for the anecdote. That's a good one. All right, I'm going to come over here and see what's going on. Oh, this looks like some conductive paint. Hello there. Can you introduce yourself?
All right, my name is Leslie, and yeah.
What are you making?
So currently it's my first time here at this workshop. So what I'm currently doing is I'm trying to conduct my art and being able to conduct music through it.
Mm-hmm.
So at the back of here, I have some of these wires connected. I don't know what's really called. It's my first time.
That's okay.
Connected to this in the computer to make it think it's a keyboard. So I have my bronze right here, and then my screws. So when I touch it, it makes music. So I'm trying to make different flowers. So
with different conductive materials.
Yeah,
this
and then
holographic thing is lovely.
Right? I was like, I'm trying
really
to use
nice.
different colors, like the gold vinyl and
I
paint.
think there's some conductive fabric in the other room.
Oh, really?
Yeah. I'll once I finish the live stream, I'll bring it
All
over.
right, perfect.
So you can have a go on that as well.
So it's just really.
And what's this one? Is this the paint?
Yeah, this is the paint. My first time
Show
actually
us
using it.
Show the paint for people who haven't seen it.
Let's see. All right, so we did it right here a little bit.
Yeah.
We have a little bit of paint right here on the corner. So what I'm gonna do is just gonna use the white one, and connect it to the very top.
Yeah.
And then just reset this so I know that I connected something new. So when I touch the black one, the black paint, it conducts the same music that I want.
That's cool.
So sometimes it's so cool because like my first time doing it. So
It is.
I'm
really
learning
cool.
so much.
It's really awesome. Thank you for sharing your project with us, and I'll come back later with some new materials for you. All right, let me run back over here and see what Nandini is. Nandini, hi. Can I talk to you about your lab?
Sure.
This is Nandini, who we've been working with in this lab for some time. This is actually her lab, so I wanted you to tell us a little bit about CETI. Do you mind showing
Sure.
us around?
Yeah, I'm paranoid about cameras, but anyway, that's okay. So CETI is sort of a collective. I happen to sort of maybe heard the collective a little bit, but it sort of stands for Creative and Emergent Technology Institute, and it's bringing people together across disciplines, bringing art, emerging technology of different kinds to do things in the world, whether the things are critical, whether they're functional, or whether they're just creative and experimental. But it's a space for people to learn in a more informal setting through making, through experience, through projects. We hold hackathons, we have workshops and intensives, we stream talks, but we do things around the breadth of technologies and art. So things with just hands-on drawing, digital design, fabrication, electronics, but also VR and creative coding, installations. But the goal is to have a space where artists and engineers and technologists can sort of play together and collaborate.
So how can people find out about this? Can they support your work? How can they come down, use the workshop? How?
We have, so go to the website. It's just CETI.institute. We talk a lot about the kinds of things we are. It's a work in progress. CETI is really new, and come join and help sort of influence its future. We have a lab, a lovely space that you've been seeing a little bit at Portland State University. It's 1855 Southwest Broadway if you're like local, but otherwise when you drop into Portland, but reach out we're on Instagram at CETI.institute. We're on
Discord as well, don't you?
Yeah, we have a Discord. Join the conversation. We have many sort of people playing one projects who are not local. And the idea is to build this community that is a little bit decentralized, that likes working on things across disciplines and across issues and subjects. So yeah, join us.
Really, really awesome. Thank you for showing us Ryan Bandini. I am going to bring this back in. Wait, hang on a second. And solo. Here we go. I'm back. So let me get down here. So before I'm actually gonna hang on. Let's solo this one. I think it's getting a little bit loud in here to carry on live streaming, but we've had a really great chat. We spoke for a bunch of time with Sean Croxx, aka Xobs, about his past portfolio of awesome open source hardware and about his upcoming Farpatch crowdfunding campaign, which we'll be doing with Crowd Supply. And we've had a look around, seen some of the really awesome projects here. There's all sorts of projects going on here, from like traditional hardware hacking to first-time people making art. So it's been really nice. And if you are in Portland, you are very welcome to come along to this today. We'll be here until 4 o'clock, and Crowd Supply is buying lunch as well. So if you get down, we'll get you something delicious. And if you can't, if you're around tomorrow, we are going to be meeting up at the bar between 2 o'clock and 6 o'clock at the Hardware Happy Hour meetup, which is at the Buy and Buy in North Portland. So if you are in the region, please do come down and say hello. If not, I will see you again at a more regular time in a more regular space back in the office in a couple of weeks. So thank you all for joining us, and hi to everybody here. This was fun. Please do leave feedback on the sound quality, because I probably need to get some new microphones if I'm going to do this in person again. But so we shall see if the lapel mic holds up. I'll listen to this afterwards. As always, please do not forget to like and subscribe. And feel free to share this, and I will see you in a couple of weeks. TBD exactly when, because we're moving office again, hopefully for the final time. So that's this. Hopefully you've had fun. It is really fun here, and have a really great rest of your Saturday. And if you're around, maybe see you. Okay, bye. John, wave goodbye, John. Come and say bye.
Bye.
Bye.